Ya, 1,90, yo soy 1,80.
Estamos haciendo, sí, no es video.
Bueno, nosotros seguimos en vivo en YouTube.
Buenas tardes a todos, gracias por venir. Este es el final de la materia Integración 4, que es en el nivel de cuarto año de Ingeniería Química. Y los alumnos, los casi profesionales, realizan su proyecto, lo inician en este año para terminarlo en Integración 5. Este es el resultado de unos coloquios previos con los alumnos, los profesores. Mi nombre es Luis Gizzarelli.
Mariano Tamburini.
Guerra, Pilar Pelloli,
Magalú, Iara
y Candela Antúnez.
Y el proyecto consiste en una selección de un producto, de una tecnología, las bases técnico-económicas para llevarlo a cabo, un estudio de mercado, localización, que se va a desarrollar en el transcurso de esta charla. El año que viene culmina este proyecto con el detalle de toda la ingeniería, todo lo que es cálculos de equipos, y también hacemos hincapié que la primera parte de la exposición lo van a relatar en inglés, como una muestra de que el inglés is very important for nowadays. So, I leave you with the expositors.
Bueno, como ya dijo Luis, les damos la bienvenida a nuestro proyecto final, a la primera instancia de este proyecto en el marco del examen de Integración 4, en el examen final. En esta oportunidad vamos a hablar de nuestro proyecto que hemos elegido, el proceso productivo de fosfato diamónico. Como dijo, mi nombre es Pilar,
Mariano, Iara Magalú
Y Candela.
Bueno, vamos a comenzar, vamos a dividir este proyecto en ocho secciones principales. La primera es un breve resumen del proyecto y será dado en inglés. Okay, at first, the summary. This is the reason that we choose the ammonium phosphate for this project. Argentina is an important producer of different crops, for example, wheat, corn, soya, and others, and it's required nutrients for the growth. These nutrients are supplied naturally by the ground, but sometimes it's not sufficient for this. So, for this reason, fertilizers are used. The plants absorb ammonia to produce amino acids, chlorophyll, and proteins to the growth. We saw in the last years that the demand of the ammonium phosphate has increased, and this product, and we saw a business opportunity to replace the 20% of the imports in Argentina. We say that the ammonium phosphate is the most important fertilizer, and it's the most commercialized because it has a high content of ammonia and phosphorus. We saw this is the product and the molecular form, and it has for the main use like a fertilizer, and others like fire retardant, a nutrient in wine making, additive in cigarettes, and others. For example, in soldering, in the metal industry. Here we have the properties. The Npk formulation of the ammonium phosphate is 18% of nitrogen, 46% of phosphorus oxide, and it doesn't have any content of potassium. The physical status we saw it's solid, and the color is it's brown and sometimes green, dark green. The pH is between 70.5 and 8. It depends. conditions, we are explain the properties in normal conditions, and the melting point is 155 degrees. Here we have the solubility in water and the density in normal condition too. And the solubility in water is bigger than the solubility in water of sugar. For example, for the diammonium phosphate is 619 grams per liter, and the sugar solubility in water it's around 200. The density is similar like sugar. For the diammonium phosphate is 619 kilograms per cubic meter, and the sugar density is 1,600. It has highly corrosive in steel and aluminum. So we have to speak about fertilizers. We use the Npk formulation. The Npk formulation is the way to describe the compositions of fertilizers. But it's information about the quantity of the main nutrients in the mineral fertilizers. The main nutrients are nitrogen, phosphorus, and ammonia. And potassium, sorry. It's not the mass composition in the mineral fertilizer, so it represents the amount of the main nutrients in the similar form. For example, the quantity of nitrogen is the plants absorb this in form of nitrogen. The quantity of phosphorus is phosphoric oxide, and the composition in the mineral fertilizer of potassium are potassium oxide. The Npk formulation in the ammonium phosphate, for example, is 18%, 46%, and 0%. It represents, I said, nitrogen 18%, 46% of phosphorus, and nothing else for potassium.
Okay, very good. As Pilar says, to produce the ammonium phosphate, we need ammonia, phosphoric acid, and to produce the ammonium phosphate. Here we have some properties of the raw materials. In the first part, we have phosphoric acid. It has a molar mass of 98 grams per mole. It's very toxic and it's explosive. And in the other hand, we have ammonia that it has a 17 grams per mole molar mass, a density of 0.73, and in normal condition, it's colorless and liquid. Our raw materials we are going to buy in two different companies. The phosphoric acid is from the USA, and we are going to buy it in the Mosaic Company and Inofos Holding. And in the case of the ammonia, we are going to buy it here in Argentina, in Bunge and Profer. Also, we made a study of our competitors. Here in Argentina, we don't have any producers of the ammonium sulfate, but we have all around the world. There are some ones like the Mosaic Company that are from the USA, or Fosfato Group from Russia, or Sabic from Arabia. But in Argentina, we have some importer or traders, and they are YPF, Bunge, or Perfect. Our plant capacity is going to be about 59,000 tons per year, and it's based in the apparent consumption that is about 295,000 tons per year. And our environmental impact is 49. That it means that our plant is going to be a third category. And this is important to understand where we are going to localize them.
Well, now we are talking about the plant location. To define the plant location, we made a comparison between three cities: Zárate, Campana, and Escobar. For this, we analyzed different topics between the cities, and we made a weighted point method. And finally, we choose to install our plant in el Parque Industrial y Logístico Paraná de Las Palmas. This industrial park accepts factories of third category. For technology selection, we are going to analyze the main two technologies, TBA process and the Oliver process. The raw materials are the same in both processes, and we have phosphoric acid and ammonia. And the raw materials are the same in both processes, and we have phosphoric acid 75% and ammonia 99.6%. The TDA process consists of a pre-neutralizer, a continuous sterile tank reactor, a granulator, a rotary drum, a dryer, and a screener. And in contrast, the Doroliver process consists of 3 continuous sterile tank reactors, 1 mixer, a dryer, and a screener. And finally, the temperature in the equipment when the reaction to obtain that occurs, the temperature is the same are both processes and is 117 degrees. Now we are going to talk about the chemistry behind the process. First, we have a phosphoric acid production. Phosphoric acid is obtained from the reaction between phosphate rock and sulfuric acid. Second, we have MAP production. The first product obtained from the reaction between phosphoric acid and ammonia is monoammonium phosphate. And third, we have DAP production. When we fed ammonia in excess, monoammonium phosphate reacts with ammonia to obtain the ammonium phosphate. In this picture, we have a process flow diagram of TBA process. TBA is the short name of Tennessee Valley Authority, who designed and created this technology. The process consists of 3 main stages. First, the reaction stage, where we obtain DAP. Second, a product separation and preparation stage, where the DAP is dryer, screener, and stored. And third, ammonia recovery stage, where ammonia is recovered with phosphoric acid. In conclusion, we will select the TBA process technology to produce DAP because it's simpler and more direct than the Doroliver process, because the Doroliver technology uses 3 sterile tank reactors in series, and the TBA process, in contrast, uses only 1 sterile tank followed by a granulator. However, the products obtained by both technologies have a good conditions. Furthermore, the TBA process is the most common technology used in the fertilizers market.